Unsupervised learning can be a challenging task for several reasons. Unsupervised learning algorithms are usually applied to data that does not contain any label information, so we don't know what the right output should be. Therefore, it is very hard to say whether a model did well. For example, let's say a hypothetical clustering algorithm that could have grouped together all the pictures that show faces in profile and all the full face pictures. This would certainly be a possible way to divide a collection of pictures of people's faces, but it may not be the one that we were looking for. But there is no way, in unsupervised learning, for us to tell the algorithm what we are looking for. And often the only way to evaluate the result of an unsupervised algorithm is to inspect it manually. So there are a couple of key challenges related to unsupervised learning. Let's see them one by one. Lack of labeled data. In unsupervised learning, the model is not provided with labeled data, which makes it difficult to evaluate the performance of the algorithm. This means that the algorithm has to rely solely on the intrinsic structure of the data to identify patterns and relationships. Difficulty in interpreting results. Unsupervised learning algorithms often generate complex models that are difficult to interpret. This makes it challenging to understand the patterns and relationships identified by the algorithm, and to use those patterns to make informed decisions. Overfitting. Unsupervised learning algorithms can easily overfit the data, especially when the data is noisy or has a high degree of variability. This can result in the algorithm identifying patterns and relationships that are specific to the training data, but not applicable to new data. Choosing the right algorithm. There are many unsupervised learning algorithms available, each with its own strengths and weaknesses. Choosing the right algorithm for a specific problem can be challenging and often requires domain expertise. Scalability. Unsupervised learning algorithms can be computationally expensive, especially for large datasets. This can limit their scalability and make it difficult to apply them to real-world problems. Overcoming these challenges often requires a combination of careful data preprocessing, feature engineering, algorithm selection, and hyperparameter tuning. It also requires a deep understanding of the problem domain and the characteristics of the data.